Alright, in this section, we're not only going to see the relationship between roots and exponents, but we're going to see that roots are technically exponents. In this section, we're going to talk about rational numbers as exponents. So we're going to convert between radical and exponential notation. So our relationship between radicals and exponents is if we have the nth root of a, we can rewrite this as an exponential as a is a to the 1 over n. So our index becomes the denominator of our exponent. Similarly, if you have the nth root of a raised to the m, our m becomes the numerator and our index becomes the denominator. So let's go ahead and practice some of these. In these examples, we want to convert to radical notation. So remember that the denominator becomes the index and the numerator becomes the exponent. So if we look at x to the 1/2, this becomes the second root of x, or remember that if it's a second root, this is the same thing as a square root. So we get x to the 1/2 is equal to the square root of x. Alright, if we look at -8 raised to the 1/3, our denominator becomes our index, and we get the cube root of -8. I can simplify this. The cube root of 8 is 2. The cube root of -8 is -2. Remember that if it's an odd root, you keep the negative sign. If you wanted to evaluate this in your calculator, the important thing is you want to do -8 caret or the x to the y key, and then make sure that you put your fraction inside parentheses. Alright, let's look at another one. Let's look at ABC raised to the 1/5. Again, my denominator becomes my index, and we get 5th root of ABC. Last one, let's look at 25x to the 16th raised to the 1/2. This is the square root of 25x to the 16th. Because it is an index of 2, I don't have to write it in. If we go ahead and simplify this now, square root of 25 is 5, and the square root of x to the 16th is x to the 8th. We are going to divide by 2. Now, another way that you can do this is I can distribute my exponent. So we get 25 to the 1/2, x to the 16 times 1/2. (25 to the 1/2), that's the square root of 25. And now for this one, 16 times 1/2 is x to the 8th. If we do 16 over 1 times 1 over 2, this is the same thing as 16 over 2, which is 8. And the square root of 25 is still 5. All right, let's look at some other examples. Let's talk about converting to, we're going to also convert these to radical notation. If we start with 27 to the 2/3, this is equal to the cube root of 27 squared. I want to evaluate this, and so I'm going to do this instead. Instead of squaring 27, I'm going to put the square on the outside. I want to evaluate the cube root first. And so one thing to note is that that inside exponent can either be inside or it can be outside. It doesn't matter what order you do this in. The reason that I'm choosing to do this in this order is, to me, cube root of 27 is easier to calculate first. If I square 27, then I'm going to be dealing with a number that I'm just not sure what the cube root of that is going to be. So these can be done without a calculator. So if we do the cube root of 27, cube root of 27 is 3 squared equals 9. Let's try another example. Let's try 25 to the 3/2. So same thing. This is equal to the square root of 25 cubed. Again, I'm going to go ahead and do my square root of 25, and then I'm going to cube it. So square root of 25 is 5. Cubed is 125. All right, last example. Let's look at 16x to the 6th raised to the 3/2. This equals the square root of 16x to the 6th. Again, I'm going to put my 3 on the outside. Square root of 16 is 4. Square root of x to the 6th is x cubed. And then I want to cube this whole thing. So if I cube the 4, I get 64. 4 times 4 is 16 times 4 is 64. X cubed cubed, remember that when we raise an exponent to another exponent, we multiply. So we get 64x to the 9th. All right, let's go the other direction now. So if we start with the 5th root of 7ab, this is going to be 7ab b raised to the 1/5. We're just going to move our index. It's going to become the denominator of our exponent. We cannot simplify any further, and so we're just going to leave it like this. All right, b, let's talk about the 7th root of x cubed y divided by 4. And so if we go ahead and move our exponent, or move our index up to our exponent, we get to the 1/7. Inside will stay the same, and we just put our index as our denominator for our exponent on the outside. Okay, what about square root of 5x? This is, again, remember that even though it's not written there, this is an index of 2. And so this is equal to 5x raised to the 1/2. And we're done. Last example, we have 9, the cube root of 9 to the 4th. If we write this using exponential notation, this is 9. Our numerator is the inside number, so it's going to be 4. Our denominator is the outside number, it's going to be 3. So this is equal to 9 raised to the 4/3. Okay, so now let's go ahead and apply our rules of exponents to rational exponents. So we want to simplify the following expressions. For example A, we are multiplying, and what do we do with exponents when we multiply? We add them. So this is going to equal 3 to the 1/5 plus 3/5. We have same denominators, and so we can go ahead and add the tops, becomes 4, and we keep the bottom. So we get 3 to the 4/5. For example B, we want to divide, and what is our procedure when we divide fractions or when we divide exponents? Remember that when we are dividing, we want to subtract the exponents. So we get a to the 1/2 minus 1/4. This one, our exponents are different, and so we want to go ahead and remember, what do we do when our denominators are different? We're going to want LCD. So I'm just going to come off to the side. We get 1/2 minus 1/4. My LCD is 4. So the first fraction I'm going to multiply by 2. We get 2 over 4 minus 1 over 4 is 1/4. So this here is my new exponent. So a to the 1/2 minus 1/4, that becomes a to the 1/4. All right, last example. We have a to the negative 1/3 times b to the 2/5. All of that raised to the 1/2. So remember, on this one, we're going to distribute our exponent, and I want to multiply each one of these by 1/2. So if we look at the first one, The first one, I want to do a to the negative 1/3 times 1/2. Remember, when we multiply exponents, we cancel and multiply straight across, so I get a to the negative 1/6 times. For the b, we get 2/5 times 1/2. I can cancel my 2's, and I get b to the 1/5. The last thing that I want to do is I want to rewrite with positive exponents. So what do we do for that? Remember that if it's a negative exponent, I can move it to the other side of the fraction bar. So we get a to the 1/6 on the bottom, and we get b to the 1/5 stays on top. And that takes care of rational numbers as exponents.